This is the vernier photo gate. It's used in motion studies, like for the physics book. The way it operates is that it has an LED that sends and it's an infrared LED, and there's a detector on the other side. And if an object breaks the beam, it can measure how long the beam is broken. And so there are a variety of different timing regimes that you can use with this. And that's part of what we're going to go over in this video. So to use it, again, you're going to have the motion go through this gap in the device there. Another way to use this is to shine a laser into this hole where there is a detector that can detect the light coming from the laser. And this allows you to run a larger object through the photo gate. And we sell a laser and stand that you can use, and you can shine a laser into here, and you're measuring the time that the laser beam is broken. So the distance goes from here to wherever your laser is. And so you could put a large object through that. You could walk through it if you wanted to. So that's what that's about. If you're using that one with the laser, then there is a slide here that covers one of the detectors. And so you want to make sure that if you're using the laser part, you have this covered up. One problem sometimes that people have when they're using this is they don't realize that this is here, and they may cover it up when they don't intend to, when they're trying to time something in here. So you need to be a little careful about that. Now, I'm going to use this with the default collection mode to start with, and that is the mode we call motion timing. And it's designed for me to be able to drop this object. This is the picket fence, and I'm going to drop it through the photo gate, and I could use it to measure the acceleration due to gravity. So that's where I'll start. And then we'll go over some of the other different timing regimes that we can use. This is a digital sensor, and so it needs to plug into one of the digital ports on the device. And so I'm going to plug it in here at the top, and digital channel 1, doesn't really matter which one. And right now it comes up here, and it's using what's called gate state. So it tells me whether or not the beam has been broken or unbroken. So right now it says it's unblocked. If I come here, I block it. If I unblock it, we end up with that. And so really what the device is a timer, and it times how long it takes to block and unblock the beam. So for this lab, I'm just going to hold the photo gate up above the tabletop, and I've put something here that's a little soft so that when the picket fence falls, it won't fall off the table there and break. And so I'm ready to collect, and I'm going to use the default mode for this. To begin collection, press our collect button. It's going to scoot over to a distance and velocity graph. And what's happening is that it's waiting for us to drop the picket fence through the photo gate. And when I drop it through the photo gate, at that point it will actually collect the data. One of the things that's important is to use good technique when dropping the picket fence. I'm holding it towards the top middle there so it won't fall out of the beam when it drops. And I'm also holding it not too far above the photo gate so it's not going too fast when I drop it through. So we have our data on the screen, and now we're ready to do some analysis of the data. So the upper graph is a position time graph, and the bottom graph is the velocity graph. And we might be interested in looking at the slope of the velocity graph to determine the acceleration due to gravity. So to do this, we could run a curve fit on our lower graph. So I'm going to go to Analyze, and I'll do curve fit, and I'll do velocity. Looks fairly linear to me, so I'm going to come up and say linear. And when I do that, I get negative 9.7 meters per second squared. Not too shabby for being able to do this. So it's very easy to do an experiment where you're measuring the acceleration due to gravity using the picket fence for acceleration. So in addition to the motion timing, there are other timing regimes that you might use. One would be the gate timing, and what happens with gate timing, it times from when the beam is unblocked to being unblocked again. And so it just times that. So it would time going through and being unblocked. One of the things that you can do there is maybe give it a defined distance, and it could calculate the instantaneous velocity with that. So that's what we call gate timing. The other is pulse timing. And pulse timing, it times from the time that it is blocked until the time it is blocked again. And so blocked, blocked again. And so there are times that you might want to do that. In addition to having it just be one together, you can have multiples of these, and so maybe you block it, and then when it goes through and blocks the next one, you might use that pulse timing. The next one is the pendulum timing. It's great for studying, say, periodic motion, maybe with a pendulum, and it times the period, so it goes from here to here. So 1, 2, 3, 4. And so that's what's called pendulum timing. And another one is what we call gate and pulse. And what happens with gate and pulse is a combination of the gate and pulse. So what it will do is it will allow it to measure the instantaneous velocity as the object goes through here. So if that's a known distance. And then as it comes back through again, it will do it again. And so it's allowing us to do gate and pulse, and it's also timing from the time that it broke it here till the time that it came back to there. So that would be the pulse part of that. So the gate is this part coming through, and the pulse is from when it's unblocked back to being blocked again. And so that gives you that pulse timing. There are additional accessories that can be used with the photo gate in addition to the picket fence that we used, such as the photo gate bracket. This allows you to attach the photo gate to the vernier dynamic system. So that's one of the options there. Another accessory that you might use is the pulley bracket. This will allow you to attach the pulley, and one of the pulleys that you might want to use would be the ultra pulley. And the ultra pulley is slotted so that it can actually time the pulley as it moves around. In addition to that, we have the laser pointer. So if you want to use the laser pointer to shine into that extra port for the detector, you can do that. And if you're doing that, it is handy to actually have the stand that will hold the laser pointer, so you can have the two things together. Then the PhotoGate bar tape kit. This allows us to attach a tape that can move along, and you can set it to where it can measure the tape as it slides through the bar there. And the idea is to use something like the old ticker tape timer that you might be used to using, so it allows you to use that mode with a PhotoGate. Then we also have the cart picket fence, and so it has a different spacing there. It makes it easier to measure the velocity of carts on the vernier dynamic system. For additional information about the PhotoGate and how to use it, we've produced this introduction to vernier PhotoGate using the LabQuest app. It's available from our website, and it details some of the timing regimes that you can use, how you might use some of those accessories that we mentioned. And so it's definitely worth a download because it will help you in setting up the experiments using the PhotoGate device.